Today we are going to talk about trig values through a point. So we've talked about angles of rotation and you talked about reference angles. So what we're saying is that we have an angle that started in standard position and it rotates the positive angle, let's say. Here's my angle theta, and it terminates, could have this terminate in any quadrant, but let's just say for this sake, it's in quadrant two. And there's a point that's on that terminal side. I can find the trig values through that point by using SOHCAHTOA and the reference angle. So we said reference angle is always the angle that's by the terminal side and the x-axis and its q. So if we think about that, there's my terminal side. Now, if I'm asking you to do trig values, sine, cosine, tangent, you need a right triangle. Well, to get a right triangle to include that reference angle, you would have to drop a vertical line to the x-axis. So you're always going to be either rising to the x-axis or dropping to the x-axis. You never connect the y-axis. So now we have a right triangle. Well, if we look at that right triangle, it's got three sides. Well, I know that point is xy. To get to that point, I had to go left x, up y. And then I have this hypotenuse that we actually in this, they call it R. Well, how would you find R? Hypotenuse, I know the legs are X and Y. I'm going to do Pythagorean theorem. A squared plus B squared equals C squared. You're always going to have X and Y. So you're always going to be square rooting the sum of those sides squared. So now if I said, well, let's find the trig values. The sine is opposite over hypotenuse, y over r. The cosine is adjacent over hypotenuse, x over r. The tangent is opposite over adjacent, y over x. Now, what are cosecant, secant, cotangent going to be? Those things flip. Now, the thing that is different is now these can be negative because if you think of a point in the second quadrant, you went left and up. That's going to be negative, which means that's going to be negative and that's going to be negative. Hypotenuse is never negative because the hypotenuse is the distance from the origin. Distance is always positive. But if you think of how you find the hypotenuse, you're squaring those, and when you square negatives, they become positive. So you do want to pay attention to the fact that the signs are different. In trig, we have a little saying, and what that saying is with the signs, all students take calculus. All students take calculus. Now, what does that mean? If you have a point in the first quadrant, all trig functions are positive in the first quadrant because your x and your y are positive. In the second quadrant, sine and cosecant, it's reciprocal, are positive. Well, if you think, just looking at this picture, why does that occur? Cosine and tangent use the x, which is negative. Sine uses the y, which is positive. Third quadrant, tangent is positive and cotangent. Everything else is negative. Now, why would that happen? In this quadrant, your x and your y are negative. That's going to make that negative. But for tangent, if I have two negatives give me a positive. Cosine, fourth quadrant, is positive, and secant, sine, and tangent are negative. Now, with these problems, you probably don't pay much attention to that, but it is something that's good to know. The questions that only question you're going to be given with this. I tell you, you have a terminal side that goes through uh, -4, 3. I say find the 6 trig functions. Okay. I like to draw a picture. So I think, okay, here's my picture. -4, 3 would be this point up here. I went left 4, up 3. If it's on an terminal side of an angle, it has to be connected to the origin. You always draw a vertical. So then you think of that triangle. I went left 4, up 3. I find the hypotenuse. That's going to be 3 squared plus -4 squared equals r squared. Be careful with that. It's going to be positive. Well, most of you know this is your 3, 4, 5 triangle. The sign just really means that it's not in the first quadrant. It's from an angle of rotation. So you do your square root, r equals 5. Now, I asked you to find the 6 trig functions, sine, cosine, tangent. Make sure you always use the reference angle as the angle that you're doing SOHCAHTOA with. That's my angle, the one by the origin. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. That's -4 if you need to see that. And flip them accordingly. Now, just with like trig functions, you would want these to be reduced fractions, reduced radicals, no decimals. If you look, that was in the second quadrant. Sine is positive, cosine and tangent are negative. So just looking at one more, let's say it terminates and it goes through -5, -12. So again, I could draw a little picture and I could think, okay, where's that point? Left 5, down 12. Connect it to the origin. Connect it to the x-axis. Think of your sides. You started here. You went left 5, down 12. You need the hypotenuse. A squared plus b squared equals c squared r squared. 25 plus 144, 169. Square root, if you guys knew this one, 5, 12, 13. Hypotenuse is always positive. So now when I'm finding those trig functions, I always look at the reference angle, the angle that is by the x-axis. You want to think that this thing went around and ended there. There's my angle. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent, both negative, so it becomes positive. So again, all students take calculus. Third quadrant, tangent is positive. Those are negative. Their reciprocals would be negative. Cotangent would be positive. So that is trig values through a point. That shouldn't really, it's very much using circuit law, but it's just that you can get these negative values. That's it